The way we view the universe has changed dramatically as a result of the James Webb Satellite Telescope. Since its inauguration on December 25, 2021, several photographs taken by the biggest telescope, possibly with the highest infrared resolution and sensitivity, have gained widespread attention. The James Webb is without a doubt the most sophisticated telescope ever built by humans. The telescope is powered by an integrated science instrument module that also serves as its computer, cooling, and structural support infrastructure. The telescope's guiding camera, as well as the 4 science instruments, are stored inside the ISIM. The NIRISpec conducts spectroscopy over the same wavelength range as the NIRICam, while the infrared imager NIRICam serves as the observatory's wavefront sensor. The mid to long infrared wavelengths are measured by the mid-infrared device. The near-infrared imager, Slitless spectrograph, and fine guiding center are employed to stabilize the line of sight during scientific observations. So far, the photographs and data from the James Webb Space Telescope have shown to be well worth the $10 billion spent on developing this incredible device. On July 12, 2022, the globe saw the first images from the telescope in eons, and analysts believe these images from the world's most advanced and powerful telescope are genuine. Fully equipped and committed to unraveling the infrared universe, the James Webb Space Telescope has already provided us with breathtaking photographs of cosmic cliffs in the Carina Nebula, which reveal the initial fast phases of star formation, a previously unknown phenomenon. The James Webb Space Telescope also unveiled photographs of the exoplanet WASP-6b, the Southern Ring Nebula, Stephan's Quintet, and the spectacular deep field vista of the universe. However, this was only the first batch, and the James Webb Space Telescope has since presented scientists with even more brilliant and awe-inspiring photographs of the universe. Some of these images have perplexed astronomers and cosmologists. Since the release of these images and data from the James Webb Space Telescope, a torrent of astronomical articles has been published, with several of these articles raising concerns among cosmologists. This is because the findings of the James Webb Space Telescope overtly and consistently contradict the theory of the Big Bang. But what exactly is the Big Bang theory? The Big Bang theory is the most widely accepted cosmological model of how the universe began. Simply defined, it states that the universe as we know it began with an unimaginably hot and dense single point that expanded and stretched at first, at incredible rates, then at a more measured rate over the next 13.8 billion years to form the still expanding cosmos we see today. It appears to have evolved from observations of the structure of the universe, as well as theoretical considerations. This model provides a thorough explanation for a wide range of observable phenomena, including light element abundance, large-scale structure, and the cosmic microwave background. It is consistent with Hubble's Lemaitre law, which states that the more away a galaxy is, the speedier it moves away from Earth. The hypothesis depicts an increasingly condensed cosmos preceded by a singularity in which space and time cease to exist. According to comprehensive calculations of our universe's expansion rate, the Big Bang singularity occurred approximately 13.787 billion years ago, plus or minus 0.02 billion years ago, which is also the approximate age of the universe. The idea of the Big Bang is clear-cut and easy to understand. However, the impression of a firecracker exploding at a definite time and space, with a center that the Big Bang name conveys, is misleading, since it leaves out the fact that the infinite cosmos is actually expanding into itself and lacks a core. If anything, rather than taking place at a single instant in time, the Big Bang happened as a process occurring throughout time. This is supported by the galaxies moving away from each other rather than from a single central point. Furthermore, evidence of the heat left behind from these early times may be seen to uniformly fill the universe, and as much as we'd like to see it, the Big Bang is not something we can see, but that doesn't imply there aren't any visible indicators of it. According to scientists, we can see the heat that existed approximately 380,000 years ago. This heat blankets the entire sky and pervades the entire universe. NASA and the European Space Agency used satellites dubbed the Cosmic Background Explorer, the Wilkinson Microwave Anisotropy Probe, and Planck to map it out. The universe was at this moment remarkably smooth, with only very slight temperature fluctuations. The James Webb Space Telescope was created to observe a time in the history of the cosmos that we have never seen before. However, the Cosmic Background Explorer, the Wilkinson Microwave Anisotropy Probe, and Planck have all seen further back than James Webb, rather than witnessing the creation of the universe. The James Webb Space Telescope's primary objective is to depict the first objects that emerged as the cosmos started to cool down following the Big Bang. That time period may be hundreds of millions of years later than the one that the other satellites were designed to see, according to Dr. John Mather, a senior project scientist for the James Webb Space Telescope. Dr. Mather is convinced that these satellites detected microscopic temperature waves that were the beginnings of new galaxies. What is unknown to humans is how and precisely when the universe's initial stars and galaxies came into existence. Thus, one of the main goals of the renowned James Webb Space Telescope is to provide an explanation for these puzzling issues, and, in the end, to help clarify the mysteries of the Big Bang hypothesis, which is currently the most satisfying theory of the origins of our universe in the scientific community. However, some scientists are beginning to question the credibility of this concept in light of the brand new photographs from the James Webb Space Telescope. Most cosmological theorists have maintained the Big Bang hypothesis for many years as an irrefutable reality, but the new data from the James Webb Space Telescope is sending some into a panic, like Alison Kirkpatrick. She works as an astronomer at the University of Kansas in Lawrence, and she claims that the most recent information has caused her to wonder if everything she has done in the field has been incorrect. According to a few experts, the exceedingly small, smooth, old, and surprisingly abundant galaxies are absolutely incompatible with the Big Bang concept. According to the Big Bang theory, the universe is expanding, and there must be some bizarre optical illusion in outer space. Beyond a certain distance, galaxies and other space objects begin to appear larger as their light is thought to have left them while they were closer to us, rather than continuing to appear smaller as the distance between them grows. However, the James Webb Space Telescope pictures show them getting smaller and smaller. In these photos, even galaxies with a mass and luminosity many times higher than our own Milky Way appear to be 2 to 3 times smaller. This suggests that the cosmos is not expanding and that the redshift is not proportionate to distance. The redshift of the newer galaxies in the photos is 2 to 3 times greater. They had previously published conclusions based on Hubble Space Telescope photos showing galaxies with redshifts ranging from 1 to 5, which corresponded to the expectations of non-expanding ordinary space. They were certain that James Webb would only corroborate their theory. The James Webb Space Telescope photos instead revealed disproportionately smooth disks and orderly spiral shapes, precisely like we observe in today's galaxies, contrary to what Big Bang theorists had anticipated seeing: severely mangled galaxies jumbled by numerous collisions and mergers. The findings suggest that there were almost 10 times more smooth spiral galaxies than projected, challenging our assumptions about merging as a typical occurrence. The findings in the Panic papers suggest that there were almost 10 times more smooth spiral galaxies than projected, challenging our assumptions about merging as a typical occurrence. This data, per the account of Lerner and Scarpa, completely disproves the merger theory. According to the Big Bang theory, the most distant galaxies in the James Webb pictures are seen when they were around 400 to 500 million years after our universe's birth. However, some galaxies contain star populations that are at least 1 billion years old. Because nothing could have been earlier than the Big Bang, the writers of the Panic article argue that the existence of these galaxies proves that the Big Bang did not occur. And just as there must be no galaxies older than the Big Bang, theorists predicted that as the James Webb Space Telescope gazed further out in space and time, the galaxies would get less and fewer until there were none left, indicating a dark era in the cosmos. However, a work that has yet to be published shows that galaxies as large as the Milky Way are frequent, even hundreds of millions of years after the theorized Big Bang. According to the Big Bang theory, distant galaxies are intrinsically smaller. One galaxy mentioned in the studies is JWST, which is significantly more luminous than the Milky Way, but has a radius of about 300 light-years, which is 150 times smaller than the Milky Way. According to Lerner, the James Webb Space Telescope images aren't the only reason the Big Bang hypothesis may be incorrect. He argues that right now, the Big Bang makes 16 incorrect predictions and only one correct prediction. Its projection of helium is off by a factor of 2, while its prediction of lithium abundance is off by a factor of 20. In addition to the lack of larger and farther off optical illusions, there are also vast-scale structures that are too enormous to have grown during the time since the Big Bang. The majority of cosmologists and astronomers agree that there is a reason for each doubt that Lerner and Scarpa's article raises, and that the Big Bang theory is unquestionably still valid in light of the most recent James Webb Space Telescope findings. These observations may have shown some strange and shocking aspects of the cosmos, but that is all. The Big Bang is based on two facts. First, that distant galaxies have a higher redshift than closer galaxies, and second, that the universe is filled with a cosmic background of microwave radiation. These two facts make up two of the three pillars of evidence for the Big Bang theory, with the relative abundance of elements in the early cosmos making up the third. However, this is only the model's backbone. In recent years, scientists have built on these to develop the mainstream model of cosmology, commonly known as the lambda-cold dark matter model. This paradigm is supported by everything from the acceleration of cosmic expansion to the clustering of galaxies. According to the Tolman test, all galaxies would have the same surface brightness regardless of distance if the universe were static and not expanding. However, this isn't the case as shown by the James Webb Space Telescope photos. In these photos, the nearer galaxies are brighter on the surface than the farthest galaxies. Contrary to popular belief, redshift does not demonstrate that galaxies are speeding away. In truth, distant galaxies aren't traveling at breakneck speed. In reality, space itself is increasing, creating more distance between us. This minor distinction indicates that galactic redshift is caused by cosmic expansion rather than relative motion. Experts do not deny that what the James Webb Space Telescope discovered does not exactly match their forecasts, but astronomers were hoping to uncover this type of perplexing evidence. They feel that this is why so much money was invested in developing the James Webb Space Telescope in the first place, and they recognize that the data acquired by this amazing telescope does not prove that the Big Bang model is incorrect, but that perhaps some of their assumptions about it may be. The James Webb Space Telescope photos have sparked much more than just the widely reported attempt to refute the Big Bang. A galaxy that existed roughly 13.5 billion years ago was discovered by the telescope only a few weeks after the first James Webb Space Telescope photos were made public. The Glass Z13 galaxy is 100 million years older than anything previously discovered, with an age of about 300 million years after the Big Bang. We may be viewing the most distant starlight ever observed, according to Rowan Naidu of the Harvard Center for Astrophysics. It was discovered in James Webb's NIRICam's early release data. When converted from infrared to visible spectrum, it appears as a red blob with white in the middle. The scientists studying the data from James Webb have determined that this galaxy is the mass of 1 billion suns. It is a component of the larger view of the far-off cosmos known as the deep field. They find it to be a really surprising characteristic, but they are eager to learn more once the administrators of the Webb grant them access to the telescope so they may perform spectroscopy. Intriguing as it is, the James Webb Science Telescope has been such a revelation for the science world, unveiling series after series of mysteries in our solar systems and the cosmos beyond. Does its findings go to refute years and years of concepts that have been theorized, or will it consolidate the fact findings from previous studies? All that we can tell for now is that this out-of-the-world telescope is right now the gateway to unraveling deeper mysteries we have struggled to understand. That sums up our video for today. If you enjoyed this video, watch also the next video on your screen, which looks at the James Webb Telescope terrifying discovery on Proxima b after 6 years. Be sure to like, leave a comment, and subscribe for more exciting future topics.